Hello students, and welcome to the next lesson in topic similarity. Today we are going to look at the property of an angle bisector of a triangle. Let's understand the theorem first, and then later we will try to prove the theorem. But first, let's understand what is angle bisector. What you see on your screen is triangle ABC. We also see a line CE such that it divides angle C into two equal parts. This is called as angle bisector. Why? Because it has divided the angle C into two equal parts, hence the name bisector. So what is the theorem associated with angle bisector? Let's have a look at that theorem. It says the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of remaining sides. Let's simplify this. The bisector of an angle. We have a bisector of an angle C of a triangle, triangle ABC, divides the side opposite to the angle. Now, opposite to the angle. Here, the angle C is bisected. So, opposite side of angle C is side AB. So, it divides this side opposite to the angle in the ratio of remaining sides. What are the remaining sides of this triangle? Side AC and side CB. In simple word, it means if in triangle ABC, bisector of angle C is intersecting side AB at point E, then AE upon EB, again I am repeating, AE upon EB is equal to CA upon CB. Let's prove angle bisector theorem as true. What you see on your screen now is some additional construction made it with blue lines. I'll explain to you about them in a moment. But first, we have given data bisector of angle C intersects line AB at point E. I am repeating, bisector of angle C is intersecting AB at point E. This is our given data, and with this we need to prove AE upon EB is equal to CA upon CB. Let me repeat, AE upon EB is equal to CA upon CB. To prove this, we have done some additional construction in blue lines. Let me explain that to you. First, we have drawn a line parallel to CE. Where is C? C is here. We have drawn a line parallel to CE from point B. Upside, we have drawn it upside, parallel to. But CE and this line is parallel. Then we have extended AC. AC is here. We have extended AC till it intersects the parallel line which we have drawn from point B. The point at which these two lines meet, we are calling it point D. So this is the additional construction we have made. Now let's move on to actual proof. I have already explained ray CE and ray BD are parallel to each other, and if we consider AD as a transversal, that means this side AD as transversal, then angle ACE is equal to angle CDB. Let me make it easy for you. I have drawn AD as transversal separately here over here, and CE and DB separately. Now you can see, if we consider AD as a transversal, then angle ACE is equal to angle ADB. These two angles would be similar. Why? Because they are corresponding angle. Now let us take BC as transversal. Where is the BC? BC is over here. So let's take BC as transversal. In that case, angle ECB is equal to angle CBD. Let me show you where are those angles. Angle ECB is equal to angle CBD. Let me again draw this here for simplification. Now you can see angle ECB is equal to angle CBD. We already know EC and BD are parallel to each other. Hence, these two angles become interior alternate angle. Hence, they are similar. So, angle ECB is equal to angle CBD. But angle ACE is equal to angle ECB. Let me show you where are those angles. Angle ACE is equal to angle ECB. Why? Because CE is the bisector. So these two angles are equal. Now please pay close attention to the green highlighted portion. Angle ACE is equal to angle CDB. Angle ECB is equal to angle CBD. But angle ACE is equal to angle ECB. That means these two angles on LHS are similar. So we can conclude RHS angles are also similar. That means angle CBD is equal to angle CDB. And which are those angles? Here highlighted in yellow color. Hence we proved these two angles are similar. I'm sure you must have received some hint how we are going to prove further. Let's see how we can do that. So up till now what we have proved is angle CBD is equal to angle CDB, which are highlighted in yellow color, right? Now I want you to focus on this triangle CBD. In this triangle, we have two angles equal. So side opposite to that angle would also be equal. Based on that, we can say side CB is equal to side CD. Why? Because opposite angle to those sides are equal. Hence, in this triangle CBD, side CB is equal to side CD. Now I want you to focus on big triangle ABD, which is highlighted in blue. We already know EC is parallel to BD. Let me draw same triangle over here. Why I have done this? So that now you can apply basic proportionality theorem for this triangle. What it says? If a line parallel to the side of a triangle intersects the remaining two sides. So we have CE parallel to BD. That means CE is parallel to one side of the triangle, which is BD, and it is intersecting remaining two sides, which are AD and EB. So based on basic proportionality theorem, we can say AE upon EB is equal to AC upon CD. You can again visit our video on basic proportionality theorem if you are not understanding this. I'm just repeating once again. Based on basic proportionality theorem, we get AE upon EB is equal to AC upon CD. But wait, just now we have proved CD is equal to CB, and here is the CD. We can replace this CD with CB, right? What we get is AE upon EB is equal to AC upon CB, which is nothing but what we were supposed to prove. AE upon EB is equal to CA upon CB. We can also call it AE upon EB is equal to CA upon CB. Hence proved.